Chapter 4, Section 29, De-duplication, Part 1, Duplicate Detection. This section covers what de-duplication is, techniques to detect duplication, and how to detect duplication by Python. De-duplication is the process of detecting and handling duplicate entries in a dataset to ensure that each data point is unique and accurate. It is necessary because duplicates can skew analysis, inflate results, and compromise the overall quality of your data. So, de-duplication is essential for maintaining the integrity of your data, especially in fields like customer relationship management, inventory systems, or predictive analytics. For example, consider a CRM database where the same customer may be listed multiple times due to errors in data entry or repeated submissions. If these duplicates are not addressed, they could lead to misrepresentation of customer insights. Specifically, duplicates lead to three major problems: data redundancy, skewed results, and inefficiency. Data redundancy is a problem that repeated entries increase the size of your dataset unnecessarily. As to skewed results, analysis performed on a dataset with duplicates may produce biased or inaccurate results. Another problem is inefficiency. Duplicates complicate data integration and processing, wasting time and computational resources. Duplicates can arise from various scenarios such as data entry errors, multiple submission, and merging datasets. Data entry errors are a problem where manual input mistakes often result in the same entity being recorded multiple times. These multiple entries can be exactly the same or have slight variations. Multiple submissions occur when the same data is submitted more than once, leading to duplicate records in the dataset. For example, in an online customer survey, a respondent might accidentally submit the form multiple times due to a slow internet connection or by refreshing the page, resulting in duplicate responses. Merging datasets can also cause duplicates. When integrating data from multiple sources, differences in data formatting, naming conventions, or unique identifiers can cause the same entity to be recorded multiple times. For example, if two customer databases use different ID formats or variations of, the merging process may fail to recognize them as the same person, resulting in duplicate records. We can use several techniques to detect and manage duplicates: exact matching, fuzzy matching, and advanced method like machine learning. Exact matching is a method that identifies duplicates by checking whether records have identical values in selected fields. It compares records based on specific attributes such as ID numbers or email addresses. It is straightforward and efficient for datasets where duplicates are likely to have identical values in these fields. Fuzzy matching is a technique that identifies potential duplicates by measuring the similarity between text values rather than requiring exact matches. It is used when duplicates are not exact but are similar. For example, Donald Trump and Donald Trump might refer to the same person. Tools like the fuzzy-wuzzy library in Python calculate similarity scores to identify such duplicates. As a more advanced method, we can use machine learning algorithms and clustering techniques to detect duplicates in large and complex datasets where exact or fuzzy matching might not suffice. These methods account for patterns across multiple attributes to identify duplicates with higher precision. Let's see an example of how to detect duplicates using exact matching. First, let's create a sample dataset in this way. This dataset has some duplicates. As we can see, there are two employees whose ID is 101 and two employees with the same ID, 102. Using this code, we can detect exact duplicates in the dataset based on the employee ID and name columns. The duplicated function checks for duplicated values in the specified columns. Here, columns are employee ID and name. The keep equals false argument ensures that all occurrences of duplicate records are marked as true, not just the second or later ones. By selecting only duplicated case using square brackets, we store the result as a variable named duplicates. By displaying this variable, we can see all duplicates in this dataset. Let's see an example of how to detect duplicates using fuzzy matching. First, import pandas, fuzz, and combinations. Fuzzy Wuzzy is a library for measuring the similarity between strings. The fuzz module provides function to compare text strings and determine how similar they are. itertools is a built-in Python module that provides efficient tools for handling iterators. The combinations function generates all possible unique pairs of elements from a given list. Next, let's create a sample dataset in this way. Let's display this dataset. These two cases are not completely identical, but one of them contains a spelling mistake, so they actually represent the same entity. Next, define a function findFuzzyDuplicates, which detects similar data using fuzzy matching. This function has three arguments. The first argument, df, accepts the pandas data frame as input. The second argument, column, specifies a column to check for similar names. The third argument, threshold, is the similarity threshold. Pairs with a similarity score above this threshold are considered duplicates. Next, initialize an empty list named matches to store similar name pairs. Next, create a for loop, which uses itertools combinations to generate all possible name pairs from the column. For example, if the list is ABC, it creates the pairs AB, AC, and BC. This ensures that each name is compared exactly once with every other name. Inside the for loop, we use fuzz ratio to calculate the similarity score. Next, create an if sentence. It states that if the similarity score meets or exceeds the threshold, the pair is considered similar. Then, it appends the similar name pair and the similarity score to the matches list. The last part converts matches into a pandas data frame and returns the result in a structured table format. The output columns are original name, matched name, similarity score. Then, apply the findFuzzyDuplicates function to the name column of the dataset to detect similar name pairs using fuzzy matching. The output table shows that John Adams and John Adams were detected as similar names with a similarity score of 95. The high similarity score indicates that This is likely a minor spelling variation rather than a truly different name. This confirms that the fuzzy matching function is correctly identifying spelling errors and name variations. Thank you for watching. Please thumbs up and subscribe to my channel.